Python and SQL can be used together. In particular, a Python program can construct and then execute SQL statements. Let's take a look. Here's a Python program. There's a built-in module called SQLite 3. SQLite 3 has a class called connection. To construct a connection, I pass in the name of a database file. It could be anything. How about n.db? And this connection object can be used to execute SQL statements. So for example, I can execute select2 union select3, which would give me a 2-row, 1-column table, semicolon. Now just constructing this table won't allow me to do anything with it. If I want to give it a name within the database, then I write create table. These are numbers, so I'll call it nums. So here we see how Python and SQL work together, is that within Python I can construct a string that is a SQL statement and execute it on some database. Now I haven't run the program yet, so nothing's happened, but let's execute one more. Let's execute an insert into statement. I could explicitly write out the values 4, 5, 6, or I could write a Python expression that computes the values 4, 5, 6. For example, the range 4 through 7, not including 7. And then I can include in my SQL statement some holes that get filled in by the data passed in as the second argument to execute. So in this way, we can construct any sequence we want using Python and then integrate that into a SQL statement. So here we've created a table, changed that table. We can also read from the table by executing select star from nums. Oh, and I forgot a semicolon up here. I'll need those too. When I select star from nums, execute returns what's called a cursor object, and this cursor has a method called fetchAll, which will fetch the contents of the resulting table as a list of tuples. Let's print those out so we can see what happened. And finally, let's clean up the syntax of our SQL statements. Everything else looks okay. Let's see what happens when we run it. All right, here's what Python printed out. 5 tuples, each one has one element, and that element is the contents of the row. When you modify a table, to ensure that the file representing this database stores all of the changes, there's one more method you need to use, which is called db.commit. If committing is successful, then this file contains all the contents of the database, just as you constructed it by executing this series of SQL statements. Every time I run this program, a file called n.db is constructed. Let's run it again. There's n.db. If I start SQLite using n.db as my database, then in fact, all of the contents that Python put into that database are there. There's a table called nums, and it has 2, 3, 4, 5, 6 as its contents. So that's how you can write a Python program that interacts with a SQLite database. And similarly, you can write Python programs that interact with lots of different kinds of databases. It happens to be that this one is built into the standard library, whereas other ones you have to install the connections.